Exercise 704 is called direct linear variation. Now, let me just reassure you that this is just a particular type of linear modelling, a special situation. So, last exercise you looked at linear modelling, relationships in the real world, where when we graph them, we get a straight line. This is still similar. There'll be situations in the real world where a linear relationship exists. However, these examples that you'll see in this exercise are what we call direct linear variation. So we look for those words in the description like direct or varies. Varies is a key word to look for, and so is direct. Now, you're becoming very good at paying attention to all the detail, and this is just another situation where you still have to practice that, where you're paying attention now to the word varies and varies directly. Actually, those words actually written in a question. There's another really common word that they use, and you may see directly proportional. Directly proportional to something. So the pressure felt by the diver was directly proportional to the depth that he was diving. Directly proportional. It's as much about recognising key words in the question and then making a connection to the maths based on those words. So when a question has direct linear variation or directly proportional in it, we know that the graph passes through, let me highlight this, whoops, that's not highlighting. So you can see there it says the graph passes through the origin, passes through this point, 0, That's the graph. Now, if you're wondering what should go in your key points and summary for this exercise, this is definitely a point. Everyone in the class should be able to take that idea and write it down here in your summary and key points. You're writing it here. That when you come across the words varies directly or directly proportional, the graph will pass through the origin. Okay, let's go back. Now, there's a slight variation to our formula, y equals. We know that if it's linear, we've got the formula. Linear is y equals mx plus b. But now because the b is 0, because b is, remember, where the graph cuts the y-axis, and it's going to cut the y-axis at 0, then it's dropped off. So the formula could have been written for this example of linear relationships. It could have been just written as y equals mx. However, there's a slight change, and it's only a slight change. Instead of the gradient being m, the gradient is now the k, which has an important interpretation. That number that goes there is no longer just called the gradient, it's called the constant of proportionality. This is again another feature or key point that needs to go in your summary. So take these notes, write all over them like I'm doing here. You do that to your set. You make this a set of notes that's really worthwhile to you and that will help you to identify the key things that you're learning in this exercise. Underline them, point them out, highlight. Pause this video if you need to at any time so that you can identify the key points. Okay, what are some other features? And again, this is another key point from this exercise. You have to be able to recognise key features. I see this tested in multiple choice questions. What are the features of direct linear variation? You need to be aware that as the x value increases, so does the y, or if x is decreasing, so is y. If x is doubled, y is doubled. If x is multiplied by 3, y is multiplied by 3, and so on. Now, you often get asked to write the variation equation. A variation equation will look like this. A variation equation, I better write that. The variation equation will be y equals kx. Well, that's how it'll start. How will you know this? You'll know that you have a direct linear variation situation because you will read the words carefully, looking for key words. You then start with your y equals kx. Write your equation. Now you'll be given some information to work out k. So it's saying that find the value of k using some values given. Then you'll be able to write something, for example, like once you know the number for k, so k might be 0.75 and you'll still have your x. At some stage you'll be asked, if we were talking about pressure and depth, then we might change these pronumerals to something more meaningful. If y was measuring the pressure and x was the depth, then this is a much nicer equation. I will do some of the next example and then leave the rest to go through in class with you. So, example 1, the distance d that can be travelled by Grace's car is directly proportional to the volume V of petrol in her car. Grace's car can travel 465 kilometres on 48 litres of petrol. Read it again. It's a problem. How we approach our problems is we read them a couple of times and highlight and underline the key features, which are clearly the numbers and any other words, because I'm really emphasising in this exercise that the words are important. I'm going to pause the video and do my highlighting and underlining. Okay, in this question, you can see that I've underlined distance, and I'm also going to now circle the D, the capital D, because you'll see that when we fix our equation towards the end, this is where we're going to replace our y and x, and in this case I'm going to replace one of them with D. That can be travelled by Grace's car is directly proportional. And how important are those words? This is exactly what I'm saying we've got to look for, and if you don't register that, then you're going to probably not start off on the correct first step. It's directly proportional to the volume, and again, note what they've said. the letter that is that we should use for the volume of petrol. And of course, when you think about this, of course the distance you can go depends on how much petrol you have, the volume of petrol. Now, this is always given. There's always some pieces of information given. So Grace's car can travel 465 kilometres. That's clearly the distance, 465 kilometres, on 48 litres. So you'll see those numbers used so that we can find the value of K. We'll be doing this bit. Finding the value of K using the values given. Okay, I'm going to pause the video again. Okay, so now you can see I've started with y equals the kx, y, because that's what my variation equation to start with will be. I'm fixing up the pronumerals. It said here the distance is directly proportional to the volume. So instead of y, I've got the distance is directly proportional, and this is my constant of proportionality, times the volume. But we know that the distance is 465 and the volume is 48. Now, if I put those two numbers into this equation, and here they are, this number in this spot and here, you can see I have an equation, and the only unknown, or the pronumeral, is k. I can find that k by, or get that k by itself by dividing by 48. When I divide this side by 48, I get 9.6875. That is the value for k. I now put that value of k back in here, into my variation equation. And that completes part A. That might be enough for you to be able to do some of the questions from 704.